2, we kind of skipped over part of building block 2. So we're kind of rearranging the order that we're doing this unit in. So after we finish law of sines and cosines, this building block 3, we'll take a quiz, review, and test next week over right triangle trig and these laws. And then we'll go back and hit the thing that we kind of skipped over. So we're just mixing up the order a little than it is in the curriculum. All right. So as I was mentioning, SOHCAHTOA, right triangle trig, what we've been practicing up to this point in Unit 2 was only for right triangles. Okay, so we have to find something different to use to find missing parts if there's not a right angle. Okay, so if I have an oblique triangle, so it could be an obtuse or an acute, it doesn't matter. I'm just going to draw a triangle over here. We cannot use SOHCAHTOA. Okay, so I'm going to label this triangle ABC. Now, you may or may not remember from geometry, we name points, which the vertices of your triangle, those are points with capital letters. Okay, and then we're going to name the opposite side with the same letter but lowercase. So angle A is the capital A, side A is the lowercase. Okay, so then this would be side B and side C. Now, law of sines is pretty straightforward. It is a proportion. If you remember proportions, it's probably been a while. I mean, you learned proportions originally, probably in intermediate school, junior high. You have your ratios. You say this is to this as this is to this, right? But there are 3 parts of a triangle or 3 sides of a triangle. So we're actually going to have 3 ratios that are all equivalent. And we can pick any 2 of those 3 to set up a proportion to solve for a missing piece. Okay, so what the ratio is, it's sine of an angle is to the opposite side as any other angle is to the opposite side. So that's going to be sine of angle A is to side A as sine of angle B is to side B as sine of angle C is to side C. All 3 of those ratios are equivalent to each other in a triangle. Okay, you're not going to use all 3 at once. You just pick 2 to set up a proportion, right? So there will be 4 pieces in your proportion. When you set up a proportion, you have to know 3 of the 4 parts, right? You can only have 1 missing part to solve for. So you have to know at least 1 angle and side across from each other. Okay, and then the 3rd piece that you know can be any other side or angle, right? Does that make sense? So let's apply that in this first example here. It says solve triangle ABC whose side C is 12, angle C is 20, and angle A is 80. Okay, so I'm just going to sketch a triangle. I'm not drawing these to scale or anything. I'm just drawing a triangle, and I'm going to label ABC. So this would be side B, C, and A. Okay, so the given information, side C is 12. Angle C is 20. And angle A is 45. Obviously not drawn to scale. That's okay. Now, when you see these instructions, here, solve the triangle. Do y'all know what that means? Both examples here say solve the triangle. What does that mean we're looking for? Solve what part of the triangle? Do y'all know? Say it again. So like angles. Okay. Yeah. So it is angles, but it's also sides. It's everything that is not given. So there are 6 parts of your triangle, 3 sides, 3 angles. They're going to give you 3. If it says solve the triangle, that means you need to find the missing 3. Okay, so I'm just going to make a note of that. So this solve the triangle means find all missing parts of the triangle. All right. So I've got an angle and I have the side across from it for C, right? Angle C and side C. So when I'm deciding what to use for my proportion, I definitely am going to have to use C because that's the only one out of A, B, and C. That's the only one where I know the side and the angle, right? Okay, and then what's the third piece that I know? So I know I'm going to use angle C and side C. Yeah, angle A. I can't use B because I don't know angle or side B. So I can't have 2 missing pieces. I can only have 1 missing piece. So I'm going to have to use A for the other part of my proportion. So I'm going to use A and C, and this is the proportion I'm setting up because I'm looking for side A first. So I'm going to plug in what I know. I know angle C is 20, side C is 12. I know angle A is 45. Side A, that's our unknown. That's what we're solving for. So far, so good in the setup. All right. Who remembers how to solve proportions? Yeah, cross multiply. Okay, some of you may have heard it called butterfly method. So you're multiplying those that are diagonal from each other. Okay, so A times sine of 20 is equal to 12 times sine of 45. Yes, you could put sine of 20 times A and sine of 45 times 12. The order that you put them technically doesn't matter. I will always list mine with the side first, the number, and then the trig function, just because, and I don't like having the number next to the other, like 45, 12, because it's more common when it's written that way for y'all to make mistakes, either putting it in the calculator, forgetting a parenthesis, or accidentally doing the 12 times the 45 before you take sine. Okay, so I think you'll make fewer mistakes if you put the side and then the trig function. All right, what do we do from there to solve for A? How do I get A by itself? Yeah, so you just divide over, because that's the opposite of multiply. And what you do to one side, you do to the other. That cancels it out here. So that gets me A all by itself is equal to 12 sine of 45 divided by sine of 20. You're going to get to a point, or maybe you're already at that point, where you don't need to show these middle steps in black. You can go straight from the setup in blue here to this, to isolating the missing piece. Okay, so you could go straight from here to here. You can skip this middle work if you understand solving proportions well. You multiply the 2 that are diagonal from each other that are known and divide by the third known. Does that make sense? Do you remember that? So a lot of y'all will just jump straight from here to here from now on. Okay, Now it's just a calculator question. You do need to be sure your calculator's in what mode? Degree mode. I'm going to show y'all using the Desmos Scientific because this is what you're going to have when you test. This is what the calculator looks like in Aware that's built into Aware. So let me clear that out. All right. So we want to make sure DEG is showing there so that you're in degree mode. Then you can see your keyboard down here and what it looks like. So we're going to do 12 sine of 45. Remember, it automatically opens that parenthesis. You can close the parenthesis, or you see how it's already kind of there, but like as a shadow, you can just arrow out of that parenthesis and then do the divided by, and it'll pop you down to the denominator, which needs to be sine of 20. Okay, and you can arrow out, or you can just hit enter there. So this should look just like how we wrote it here. Okay, for side lengths, we are going to be rounding to the thousandths. So rounding to the thousandths, how many places after the decimal? Like how many numbers after the decimal is the thousandths place? 3 places. Okay, so 3 numbers after the decimal. Okay, but we look to the 4th number to see if we need to round. Do we need to round this up? No, we leave it at 9. Okay, so it stays a 9 because this next number is not 5 or higher. So 24.809. Oops. We don't have any like units of measure or anything like that. All right, 1 down, 2 to go. We've got 1 missing side done. So looking in this triangle, what do you think is the easiest part of this to solve for? What do y'all remember about angles of a triangle? Yeah, so when you're given 2 angles, it's actually really easy. You don't have to use law of sines or anything fancy to find the 3rd angle. You're just adding and subtracting, right? So I'm going to go ahead and do that. So I'm going to say, okay, I'm just going to use triangle sum theorem, which says the 3 angles of a triangle add up to 180. Okay, to find my missing angle. So you can add the 2 that you know and then subtract that, or you can subtract these each individually. I don't care how you do that work. If you want to add those first and then subtract, go for it. But what does that leave you with? So that is the measure of angle B. That one we do know the units, it's degrees. So it's an angle, a triangle. All right, got that one done. So got a missing side, check. Got the missing angle, check. So we just have side B left to find, right? So we still have to find side B. So using law of sines, setting up a proportion, we have to use B because that's what we're looking for. And we know angle B now, so that's good. So we'll use sine of B is to side B. But what do you think we should set that up equal to? Should we use the C's or the A's? Why should we use the C's? Yeah, going back, we've talked about this in other units. When there's more than one way to solve a problem or do the next step of a problem, always go back to use the given information rather than information that you found. So we know side A, but we calculated it. So if we messed up in calculating side A and we use that to find side B, then we get both wrong. Okay, going back to use what was given, C, that guarantees that we still have a shot at getting this correct, even if we got A wrong, right? So we're going to go back, we're going to use C. And the other reason is also because A is a rounded value, okay? let's say you did have to use this for some reason, you would just need to make sure in your calculator, when you go to do your calculations, you use the entire value here, not just the rounded part that we wrote down. Okay, don't use rounded values in the middle of your problems because it throws your final answer's decimal slightly off. Okay, but we're going to use C to avoid that. So we're going to say sine of C is to side C. All right, so angle B we said was 115. Angle C was the 20, right? And side C was 12. So I'm going to do what I said here, and I'm going to skip this middle step that was in black, and I'm going to go straight to isolating the B. Okay, because I know I should, it's multiplying the two knowns that are diagonal. So that's the 12 times the sine of 115. You don't have to, when you're writing, put the parentheses. It's probably a good habit to get in so you can make sure that it matches what the calculator shows, because the calculator's definitely going to need to have the parentheses. And then you divide by the third known, which is the sine of 20. Okay, so we're going to plug that in. Over 10. All right, so that is sine. Oh, no, it is not yet sine. It's 12 sine of 115 divided by sine of 20. Okay, so what will that be if we round to thousandths? 798. Good. The 4 will not round that 8 up. I'm going to put this into y'all's notes here. Go. I just want to have the calculator work in here, so somebody looking at this later will know how we plugged it into the calculator. Okay. All right, so that'd be 31.798. All right, so we got all 3 missing pieces, right? We're done solving the triangle. Y'all agree? Now, do y'all remember back in geometry when you were looking at proving triangles congruent or similar, y'all did all those abbreviations with A's and S's based on what information you had? So like side, 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 angle, side, angle, side, angle, side. Remember all that? So we're going to use that to help us determine when we should be using law of sines versus law of cosines. So here, looking at what's in pink, that's the given information. What would you say that this is, that you were given? It's 2 angles and a side, right? So would that be angle, side, angle, or angle, angle, side? Does it matter? Is there a difference in those? Why do you think that? Yeah, so you're correct. I just want to make sure that everybody, I'm going to follow through with what we're saying here. So we have an angle, and we have a side. That side is not connecting the 2 angles, is it? It's not in between them. So we don't say angle, side, angle, because it's not the included side. Okay, so it would be angle, angle, side, or you could say side, angle, angle. As long as you don't put that side in the middle. Does that make sense? So that is one of the instances when we use law of sines. So I'm going to jot that down. I'm going to say we would use law of sines when we have side, angle, angle, or you could say angle, angle, side. Those two are the same thing, as long as the S is not in the middle. Good? So I don't care which one of those you write. Okay, but that's one of the instances. Okay, let's take a look at this next example and see what we're given here. So I'm going to sketch a triangle again. And they're calling this one ABC also. I'll do the same, ABC. All right, now this time they give us side A is 10. Side B is 14. And angle A is 39. Okay, so this is not two sides and an angle. This is not two angles and a side. It is two sides and an angle. Okay, but what about the order of how they've given it to us? Because we have an angle and two sides. Should I say side, angle, side? Is the angle that was given in between the two sides that were given? No, we were given side A and B. Side A and side B meet at angle C. So this is not side, angle, side. It's side, side, angle, right? So side, side, angle is another instance when we will use, and I'm not going to write this one backwards. I don't want bad words on my paper. Good? All right, so let's go ahead and work this one. So what do y'all want to find first? What do we have to find first? What do y'all see? We've got to find angle B. We know A, side and angle, so that has to be part of the proportion because that's the only one that I know both of, right? I can't start with C because I don't have either part of C. I can't have two missing pieces. So I've got to start with B. Okay, so I'm going to plug in what I know. The C. So sine of 39 is to 10. And sine of B is to 14. Okay, so what's different on this one than the ones we did on that first example? The missing piece is an angle instead of a side. Okay, but it doesn't change how we start the problem. We still start by cross multiplying. So I'm going to isolate that sine of B because that's where my unknown is. So it's going to be 14 sine of 39 over 10. What's different now, though, is that I can't just calculate this and have my answer. There's going to be an extra step. What's that extra step? Because when I calculate this, that's not B. That's sine of B. How do I get just B by itself? Yeah, just like when we were doing right triangle trig and we were missing an angle, we had to do inverse trig. That's exactly the same thing here. When you're missing the angle, you're going to have to do inverse trig. So I'm going to get B by itself by doing inverse sine of all that. If you wanted to do that step first and get a decimal, and then do inverse sine of that, that's okay, as long as you do inverse sine of the entire decimal, not a rounded version of it. Or you can just enter it all at once, which is what I'm going to do. Go over to this side now. All right, so I'm going to do it on your scientific calculator here in Desmos. You have to hit this function menu to change your keyboard to see your inverse trig functions. So inverse sine, and then you have to go back to your main keyboard to get your numbers. Okay, of 14 sine of 39. Get out of that parenthesis, divide to make it a fraction. It's over 10. Get out of that parenthesis. And so that looks exactly how we had it written, right? Okay, so that is 61.76910,889. For side lengths, I had y'all rounding to thousandths. For angles, we're going to just round to the nearest degree. Okay, so the nearest whole number, the nearest integer. So what is that going to round to? 62. So angle B is approximately 62 degrees. All right, so done with angle B, check. Now what could I do pretty easily now that I know two angles? Yeah, so now I could do my triangle sum because I know two to find the third. Okay, so I'm going to do triangle sum is 180. I'm going to subtract the 39 from angle A and the 62 from angle B. And what does that leave me with? 79. So that is the measure of angle C. Now again, that is approximate though. Why is it approximate? Not exact. It's not exactly 79, is it? Because 62 was rounded, wasn't it? So it's approximately 79. For the sake of what we have to, I told you we don't use rounded numbers in the middle of problems. So in my calculator, I'm going to go ahead and do this subtraction with the decimal. So in my calculator, I'll have the exact value of C because I'm going to have to use that in the next part. So I'm going to do 180 minus the 39. What just happened? Minus what? I don't know what. Okay, 180 minus 39 minus, and then you can just copy and paste that exact value, the entire thing. Does that make sense? So we said about 79, which it is, but it's 79.23089111. Okay, we're going to keep that in our calculator to use here in a minute. All right, so now that we've got both missing angles, what's the only thing left for us to find? Side C. So we still need side C. So we're going to have to use C, obviously, in our proportion. What else should we use in our proportion? A or B? A, because A were the two original given ones. I don't want to use B because I had to calculate that one. Okay, so I'm going to use, I'm going to set up a proportion with C and A. I'm going to plug in what we know. And then I'm going to write 79 for the sake of writing. But in our notes, I'm going to put a little asterisk here by the 79. So you remember, it's not exactly 79. When I put this in the calculator, it's got to be that decimal. Okay, so when I go to solve this, it would be 10 times sine of that 79 decimal divided by sine of 39. Put that asterisk there above the 79 again. Make sure that we're going to use the entire decimal. All right, so I do clear that. Oh, crap. Well, it's good while it lasted. Let me retype this. I was just trying to delete that one line and I accidentally deleted it all. My bad. Give me a sec. Okay. So now I'm going to type in 10 times sine of this entire number. I'm going to copy and paste that. Divided by sine of 39. Copy this over for our notes. Big. Weird. I'm just going to put it down here a little bit so it's out of the way. Okay, so there's what we did in the calculator, which means angle C, or not angle C, excuse me, side C. What's that? Comes out to approximately 15 point. And then how would you write that if we're going to thousandths? Would you write that decimal? 0.610. If it says to go to thousandths and your thousandth place is a 0, write the 0. Okay, go to the place value you're asked to go to. All right, so we got all 3 parts here that we're missing, so we solved that triangle. How y'all feel about law of sines? Good? Not every problem is going to be that long and ask you to solve the triangle. I was doing all the parts for the sake of our notes, so you can see how to find all of the missing parts. Your problems will probably be more straightforward, like just solve this missing side or this missing angle, and it'll just be like one piece of that. So there are 2 wins that we listed here for these 2 examples. Hang tight, y'all. We got one thing to add here. Okay, we said if you had angle side or side angle, you could use law of sines. Let's go back and look at this triangle and see, is there any other information, 3 pieces that you could be given other than those 2 that you could also use law of sines to solve the triangle? What if I gave you angle C and angle A and side B? What if that was your given information? What would you have to do to solve that triangle? At this point, with what's given, Do you know a side and an angle that are opposite each other? No. But you do know two angles. Could you easily find the third angle? By doing triangle sum, and then you would know both B's, wouldn't you? And then you could set up a ratio for either of the missing sides. So that's the third scenario, the third set of given information where you could use law of sines. That's not one of the examples we did, but it's one of the times when you do use law of sines. So that one would be angle, side, angle. Okay, so we're going to add that down here. Oops. So angle, side, angle. So those are the three scenarios based on the information given for the triangle that you would use law of sines to find the missing pieces. Good? All right, so y'all can put it away for now. We're going to do law of cosines tomorrow. Don't forget to go back and look at your delta math. I'll actually pull it up real quick here. I went and added in, let me do the sample student page. So it's this assignment, the right triangle trig practice. It was originally supposed to be due tonight, Wednesday, but I added in this section of word problems based on yesterday's notes. So you need to do 5 from this section. So I extended the deadline through the weekend. Okay, you will have class time on Friday, homecoming carnival day. You will have class time to work. If you have done everything else on this, you just have these new 5 problems. You can work on those in class Friday. If you want to knock them out before then, that's up to you. But you will have class time to do those. So you really shouldn't have any additional homework unless you haven't done the rest of this already that was supposed to be due tonight. I would go back and get started at least on some of that. All right.